We all love playing with magnets. In the last program, we had discussed about the discovery of magnets, various magnetic and non-magnetic materials, and about the poles of the magnet. After getting to know so many interesting things about magnets, let us see how they were used to find directions in the earlier times. Magnets and many of their properties were known to the people from ancient times. You might have read many interesting stories about the uses of magnets. One such story is about an emperor in China named Huang Ti. It is said that he used a chariot with a statue of a lady that could rotate in any direction. It had an extended arm that pointed a specific direction. Interestingly, the statue would rest in such a position that its extended arm always pointed towards south. By looking at the extended arm of the statue, the emperor was able to locate directions when he went to new places on his chariot. Why not make a direction finder for ourselves? Isn't that interesting? So, let us do an activity for this. Take a bar magnet, put a mark on one of its ends for identification. Now, tie a thread at the middle of the magnet so that you may suspend it from a wooden stand. Make sure that the magnet can rotate freely. Let it come to rest. Mark 2 points on the ground to show the position of the ends of the magnet when it comes to rest. Draw a line joining the 2 points. This line shows the direction in which the magnet was pointing in its position of rest. Now, rotate the magnet by gently pushing one end in any direction and let it come to rest. Again, mark the position of the 2 ends in its position of rest. Does the magnet now point in a different direction? Rotate the magnet in other directions and note the final direction in which it comes to rest. Do you find that the magnet always comes to rest in the same direction? Now, can you guess the mystery behind the statue of the emperor's chariot? Yes, you must be guessing the correct reason. The statue actually had a magnet inside it. We find that a freely suspended bar magnet always comes to rest in a particular direction, which is the north-south direction. You can also use the direction of the rising sun in the morning to find out the approximate direction of north and south. The end of a magnet that points towards north is called north-seeking or the north pole of the magnet, and the other end is called the south pole of the magnet. All magnets have a north pole and a south pole, whatever their shape may be. This property of the magnet have been used for centuries by the travelers to find directions. In earlier days, travelers used to find direction by suspending natural magnets with a thread which they always carried with them. Later on, a device known as a compass was developed based on this property of magnets. A compass is nothing but a magnetic instrument which is used to know the direction, mostly for navigation. A compass usually consists of a small box with a glass cover on it. A magnetized needle is pivoted inside the box, which can rotate freely. The compass also has a dial with directions marked on it. The compass is kept at a place at which we wish to know the directions. Its needle indicate the north and south direction when it comes to rest. The compass is rotated until the north and south marks on the dial are at the two ends of the needle. After knowing about such interesting properties of a magnet, I'm sure that you must be waiting to make magnets of your own. There are many methods of doing this, but let us discuss the simplest one. What you have to do is first take a rectangular piece of iron and place it on the table. Now, take a bar magnet and place one of its poles near one edge of the iron bar that you have taken. Without lifting the bar magnet, move it along the length of the iron bar till you reach the other end. Now, lift the magnet and bring the pole with which you started to the same point of the iron bar from which you began. Move the magnet again along the iron bar in the same direction as you did before. Repeat this process about 30 to 40 times. Bring a pin or some iron filings near the iron bar to check whether it has become a magnet or not. If not, continue the process for some time. One thing that you should remember is that the pole of the magnet and the direction of its movements should not change. If you want, you can also use an iron nail, a needle, or a blade and convert them into a magnet. So, having known how to make your own magnets, don't you think it would be more interesting to make your own compass, about which you must have heard in movies, voyage stories, etc., and about which we discussed some time back only? For that, let's do another interesting activity. First, magnetize an iron needle using a bar magnet. Now, insert the magnetized needle through a small piece of cork or foam. Let the cork float in water in a bowl or a tub. Make sure that the needle does not touch the water. Your compass is now ready to work. Make a note of the direction in which the needle points when the cork is floating. Rotate the cork with needle fixed in it in different directions. Note the direction in which the needle points when the cork begins to float again without rotating. Does the needle always point in the same direction when the cork stops rotating? You observe and answer. I know you all love playing games. So let's play an interesting game to understand the attraction and repulsion between the magnets in a better way. You have to take two small toy cars and label them A and B. Now, place a bar magnet on top of each car along its length and fix them with rubber bands. In car A, keep the south pole of the magnet towards its front. Place the magnet in opposite direction in car B. Now, place the two cars close to one another. What do you observe? Do the cars remain at their places, or do they run away from each other? Do they move towards each other and collide? Record your observations in a table. Now, place the toy cars close to each other such that the rear side of car A faces the front side of car B. Do they move as before? Note the direction in which the cars move now. Next, place the car A behind car B and note the direction in which they move in each case. Repeat this activity by placing cars with their rear sides facing each other. Also, record your observations in each case. Now, tell me, what do we find from this activity? Do similar poles attract or repel each other? What about the poles which are opposite to each other? Do they attract or repel? After this activity, you must have found that similar poles repel and opposite poles attract. A few cautions which you should remember while studying about or using magnets is that they lose their properties if they are heated, hammered, or dropped from some height. Also, magnets become weak if they are not stored properly. To keep them safe, bar magnets should be kept in pairs with their unlike poles on the same side. They must be separated by a piece of wood, while two pieces of soft iron should be placed across their ends. For horseshoe magnets, one should keep a piece of iron across the poles, and the most important thing, keep the magnets away from cassettes, mobiles, TV, music system, compact discs, and computers. So, this brings us to the end of the chapter. Let's summarize the important points that we have discussed today. The first point was, each magnet has two magnetic poles, north and south. Next, a freely suspended magnet always aligns in north-south direction. And the last one was, opposite poles of two magnets attract each other, whereas similar poles repel one another. I hope you learned many new things in this segment. Let's revise and check how much have you understood and how much do you remember. Hence, answer the questions. In the first question, you will have to fill the blanks. The first one is, there should be dash poles in a magnet. The answer is, there should be two poles in a magnet. The next one, in olden days, sailors used to find direction by suspending a piece of dash. In olden days, sailors used to find direction by suspending a piece of barred magnet. In the next question, you will have to tell me whether these statements are true or false. The first statement is, there is only one pole in a cylindrical magnet. This was a false statement. There are actually two poles in a cylindrical magnet. The next one, in a magnet, similar poles repel each other. Yes, it was a true statement. The next one, bar magnet always points towards north-south direction. Yes, this statement too was true. Moving on to the next question, you will have to answer to what positions of the poles of two magnets the resultant action will be attraction or repulsion. The first condition is the north and north pole together. What will be the resultant action? The resultant action will be repulsion. The next